Hi guys! Today we're going to look at how to respond to player input and make a top-down 2D character move around the scene. This is the first video in our series showing how to make a full top-down 2D shooter game. Okay, let's get started by opening Unity Hub. We'll click New Project and select the 2D URP template. This will give us an empty project, configured with everything we need to create a 2D game. We'll give the project a name of 2D Top-Down Shooter. Then we'll click Create Project. It will take a while to create the project, but once it's finished, Unity will open up. For those of you not familiar with Unity, we'll do a quick overview of the main elements of the UI. The main panel shows us the view of the scene being edited. Using the tabs at the top, we can switch between Scene View and Game View. The Scene View is used for placing and editing objects in the scene. The Game View shows us the scene viewed through the game camera, so basically what the scene will look like when it runs. On the left-hand side, we have the hierarchy. This contains all the objects that are in the scene. Unity has given us a couple of objects to start with. We've got a camera, which will be used to decide which objects in the scene are shown to the player. We've also got a global light, which is used to light the scene. On the right-hand side, we have the inspector. This shows us details and settings relating to the object we currently have selected. For example, if we select the camera, the inspector then shows various settings for the camera that we can change if we want. Down at the bottom, we have the project panel. This contains all the assets for the game. So this will be things like images, audio clips, and animations. It already contains a folder for scenes. If we click on this, we can see that there's a scene asset called Sample Scene. This is the open scene that we're looking at here. Ultimately, a game will be made up of many scenes. For example, you may have a scene for the main menu and another for each of the levels in the game. Let's right-click on the sample scene and select Rename. We'll rename it Game, as this will be the main game scene. We'll click Reload to reload the scene. Now let's add an object to represent the player. We'll click the plus button on the hierarchy and select Create Empty. This has created a new object in the scene. We'll name this Player. We can see in the inspector that this new object has a position, rotation, and scale. Every object in the scene will have this transform component. We can then use the Add Component button to add more components that provide more functionality to the object. For example, if we switch to the game view, there is still nothing for us to see. Let's add a component to change this. We'll click on Add Component and search for Sprite Renderer. This will add a component that will display a sprite for the object. We need to select a sprite by clicking the target icon. Then we can select one of the sprite assets we have available. We'll import some better sprites in a future video, but for now we'll click the eye icon to show all hidden sprites. Then we'll search for hexagon and choose one of these. We now have a hexagon visible in the scene to represent the player. The next thing we'll look at is how to make the player move. If we change the transform position X value in the inspector, we can see that the player moves left and right. If we change the Y value, we can see the player moves up and down. We want to be able to control these movements based on input from the player. To do this, we'll need a few more components. Let's click the Add Component button again and search for Rigid Body 2D. This adds various settings and puts the movement of the object under the control of Unity's physics system. To demonstrate this, let's press the play button to start the game. We can see the player now falls and disappears off the bottom of the screen. This is because gravity is now acting on the object. Let's stop the game again and go to the rigid body settings to change this. As this is a top-down game, we don't want gravity to apply, so we'll set the gravity scale to 0. Let's press play again. Now gravity has no effect and the player stays completely still. Let's stop the game and add some custom code to make the player move. For this, we're going to need to create a new script. We'll go to the Assets section of the project panel. We'll click the plus button and select Folder. We'll call this Scripts. We'll put all our scripts in this folder to keep things organised. We'll add some more subfolders to help us find things once we have more scripts. We'll double-click on the Scripts folder. Then we'll click the plus button and add another folder. We'll call this one Game. This is the name of the scene that the script is for. We'll add one final subfolder to this. We'll double-click on the Game folder. Then we'll click the plus button and add a folder again. We'll call this one Player. This is where we'll put all the scripts relevant to the player. Now we have our folder structure set up, we'll create the script. Let's double-click the Player folder. Then we'll click the plus button and select C# script. This script is going to contain all the logic for player movement, so we'll call it Player Movement. To assign this script to the player, we'll select it in the hierarchy. Then we'll click the Add Component button and search for Player Movement. Next, we'll double-click the script to open it in the editor. Unity has created a default C# script with a couple of methods. We'll delete these as we aren't going to need them. In a script, we can get access to other components attached to the game object. As we want to move the object, we'll need the Rigid Body 2D component, which will allow us to set the velocity of the object. We'll create a private field to hold a reference to the Rigid Body 2D. Then we'll make use of Unity's Awake method. Unity will call this method when the scene is first initialized. In here, we'll use the getComponent method to get a reference to the Rigid Body 2D component and assign it to the field we created. This will find the Rigid Body 2D component attached to the game object and store the reference in the field for us to use. Next, we'll add Unity's FixedUpdate method. This method is called at the frequency of the physics system, and any changes to a rigid body are recommended to be made inside this method. We'll set the velocity of the rigid body. This is a vector2 value which has two parameters, one for x and one for y. We'll set x to 1 and y to 0.5. This is saying we want the object to move at a speed of 1 unit per second on the x-axis, which is left and right, and 0.5 units per second on the y-axis, which is up and down. Let's save this script and switch back to Unity. We'll press the play button to try it out. We can see the player now moves across the screen. The next stage is to allow us to control the direction of this movement with input from the keyboard or a gamepad. For this, we're going to install the new input system that Unity recommends to use over the default system. We'll stop the game and select Window, Package Manager from the main menu. Then, from the drop-down at the top, we'll select Unity Registry. This will allow us to install additional Unity packages. We'll search for Input System. Then we'll click on Install. We'll click Yes to enable the new input system. This requires Unity to restart, so we'll save the scene when prompted. When Unity restarts, we can close the Package Manager. Then we'll select the player in the hierarchy. We'll click on Add Component and add a Player Input component. This will add a component for processing player input. For this to work, we need to create some input actions. We'll click the Create Actions button. In the pop-up, we'll right-click and select New Folder. We'll name this Input. Then we'll double-click to go into the new folder. We'll name the file Input and click Save. We're now looking at the default input actions that Unity has created. We can see there are actions for Move, Look and Fire. The input we're interested in is the Move action. If we expand this, we can see it's bound to the gamepad left thumbstick. It's also bound to the WASD keys and the arrow keys. So input from any of these sources will be treated as movement. We could change these bindings to anything we wanted, but we'll leave it as it is and close this pop-up. we'll navigate back to the script editor. The player input component we added allows us to receive messages when the configured input is received. If you remember, the input action was called move. To receive a message regarding this input, we simply add a method called onMove. It may try to auto-populate the onAnimatorMove method when you do this. If it does, just manually change it back to onMove. This method will be called whenever there's a change to the input bound to the move action. So, when the left thumbstick is moved or the relevant keys on the keyboard are pressed. When the method is called, it will provide us with the input value as a parameter. To be able to use this, we need to add a reference to the Unity Engine Input System namespace at the top of the script. From the input value, we can write this code to get the vector2 value. This will represent the direction and magnitude of the input. For example, if the right key on the keyboard is pressed, then the x value of the vector will be 1. If the W and D keys are both pressed, we'll get a vector with a value of about 0.7 on the x and y axis, representing a diagonal direction. We need to store this value so we can use it in the fixed update method. We'll add a private field for this called movement input. Then we'll set this to the value we got in the onMove method. Now, in the fixed update method, we can use this value to set the velocity. This will set the velocity so that the object moves in the direction of the movement input. Let's save this and switch back to Unity. We'll press play to try it out. Now, when we press the keys or use the gamepad thumbstick, the character moves around the scene. It's moving a bit slowly at the moment though. Let's stop the game and switch back to the script to see how we can increase the speed. What we'll do is add a new private float field called speed. A float allows us to store a number with decimal values, so we could set the speed to 4.5 units if we wanted to. We'll make it private as we don't want other scripts to be able to access this variable and change the value. We do want to be able to set this value from Unity though. We can allow this by adding the serialized field attribute. We can now multiply by this speed value when setting the velocity. So the velocity is now the movement input multiplied by the speed. Let's save this and switch back to Unity. If we look in the inspector, we can see there's now a field to set the speed. We'll set this to 5 and press play. Now the player moves much faster. Okay, that covers everything for this video. In the next video in this series, we'll look at how to make the movement a bit smoother, so it doesn't stop and start so suddenly. We'll also add some assets to improve the appearance of the player character. If you want to be alerted when this one is out, then subscribe and click the bell icon. If you have any questions or feedback on this video, then let us know in the comments. A big thank you to all our patrons. We really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. Thanks guys!